All right, let's dive right in. We're going to go deep into the mind of an AI and answer one of the most important questions out there right now. How does it actually remember stuff? We're moving beyond those forgetful assistants and into a wild new era where AI finally has a memory.
You know that feeling, right? You spend 10 minutes giving an AI all the perfect context, you have a great back and forth, and then you start a new chat, and poof, it's gone. A complete blank slate. That feeling of having to start over from scratch, well, that's at the very heart of the problem we're going to solve today.
I just love this analogy because it hits the nail on the head. For so long, AIs were stateless, and that's exactly what it means. Every single conversation was like writing on a Post-it note that you just crumple up and throw away the second you were done. No memory, no history.
So yeah, let's properly unpack this. We're talking about AI's huge memory problem, and really, it's all about this fundamental jump from being stateless, forgetting everything instantly, to becoming stateful, where they can actually learn and remember from one conversation to the next.
Look, we've all seen short-term AI memory. You ask a follow-up question in the same chat, and it gets what you're talking about. But that's just a temporary scratch pad. The real game changer, the revolution we're here to talk about, is long-term memory. It's the AI remembering who you are, what you're working on, and your preferences over days, weeks, months, turning it from just a fancy calculator into a real collaborator.
Okay, so how in the world do you build a memory like that? Well, it all starts with a really fundamental shift in thinking. You have to teach the machine to understand not just the words you're typing, but the meaning behind them. And the only way to do that is to translate our messy human language into the universal language of math. And the magic ingredient for this translation is a concept called an embedding. The best way to think about it is like a GPS coordinate system, but for concepts. An embedding takes any piece of data, a word, a sentence, even a picture, and turns it into a long list of numbers, a vector, that pinpoints its meaning in this huge, multidimensional map of ideas.
And this is where it gets really cool. This meaning map lets you do math with ideas. This is the classic example, and for good reason. You can literally take the vector for king, subtract the vector for man, add the vector for woman, and the resulting vector is incredibly close to the one for queen. The model has actually captured the relationships between these concepts purely with math. It's wild.
So how does this actually happen? Well, you feed raw data, some text, an image, you name it, into a specialized deep learning model. The neural network just chews on that data, analyzing all the context around it, and then it spits out this really long list of numbers. We're talking a dense vector with like 1536 dimensions or more, where every single number captures some tiny, subtle nuance of the overall meaning.
Okay, fantastic. We can turn meaning into numbers. Now what? Where do we put all these incredibly complex, high-dimensional coordinates? I'll tell you what, you're not going to just stick them in a spreadsheet. You need a special kind of library, one that's designed from the ground up to handle meaning.
And that brings us to the next key piece of the puzzle: vector databases. These things are purpose-built systems. They have one job, and they do it exceptionally well: to store, manage, and search through millions or even billions of these embedding vectors at lightning speed.
Now, to really get this, just think about how different this is from a traditional database. A normal database finds exact keyword matches. You search for AI regulation, it finds the words AI regulation. It's rigid. But a vector database? It searches based on the vibe, on the meaning. It finds documents that are semantically similar. So it won't just find your exact phrase. It'll find an article about the legal frameworks governing artificial intelligence, even if your keywords aren't in there at all.
And just to be clear, this is not some theoretical, far-off tech. This is happening right now. You have huge companies like Pinecone, Weaviate, Chroma, and Milvus building the fundamental infrastructure, these semantic libraries that make AI memory possible for everyone.
Okay, let's take a breath. So we have embeddings, the language of meaning, and we have vector databases, the library to store it all in. Now for the million-dollar question. How do we actually connect this new memory to the AI's brain, to the large language model itself?
Well, the answer has a name you've probably been hearing a lot lately: Retrieval Augmented Generation, or as everyone calls it, RAG. RAG is the framework, the process, that tells the LLM, hey, before you say anything, go look up the relevant facts in that new memory we built for you. It's basically like giving an open book test to an already brilliant student.
So let's walk through it. What actually happens when you ask a question? First, your query gets turned into a vector. Second, the system zips over to the vector database and finds the most similar, most relevant chunks of information. Third, it retrieves that raw information. And finally, this is the magic moment. The LLM gets both your original question and all that juicy retrieved context. Now it has everything it needs to give a grounded, accurate answer.
So why is everyone so excited about RAG? Because it's a massive leap forward. For one, it dramatically reduces AI hallucinations, when it just makes stuff up, because it's grounded in facts. It also gives the model access to brand new or even private information without needing an expensive retraining. And maybe most importantly, it can cite its sources, which is absolutely huge for building user trust.
Okay, that's all the theory. It sounds great, but where can you actually see this stuff working today? Let's look at how this memory architecture is already changing the AI tools that we use every single day. And the truth is, it's everywhere. That chatbot that actually remembers what you said 10 messages ago, that's it. That personal assistant that knows you prefer summaries and bullet points, that's memory. Code assistants that can understand your entire code base instead of just one open file, yep. And customer support bots that can pull up your whole history with the company in a second, that is the real-world payoff.
And for all the developers watching, this isn't some complex, out-of-reach technology. Frameworks like LangChain are making this stuff incredibly accessible. I mean, look at this simple code snippet. You're just importing a memory buffer and saving context. This is the fundamental building block of giving your own AI a persistent, long-term memory.
All right, so let's boil it all down. If you walk away with just 3 things, make it these. 1. Embeddings. This is how we turn meaning into math. 2. Vector databases. These are the specialized libraries for storing and searching all that meaning math. And 3. RAG. That's the connective tissue, the process that plugs the AI's brain into its new memory, making it smarter and way more reliable.
Which leaves us with a pretty big question for the future. As these AI systems get better and better at remembering everything we tell them, our work, our preferences, our ideas, the line between a powerful tool and a personal confidant starts to get really blurry. So how do we navigate this new world? How do we get all the incredible benefits of this collaboration while making sure we always stay in control of what our AI remembers?